The James Webb Space Telescope has established itself as the world's most advanced observatory dedicated to space science. Its primary mission is to explore the mysteries of our solar system and investigate distant exoplanets orbiting stars far beyond our own. Additionally, it seeks to examine the large-scale structure of the universe and better understand our place within it. In a recent study, scientists aimed the powerful Webb telescope at a star situated approximately 120 light-years from Earth. This observation led to a remarkable discovery: the detection of carbon-based molecules in the atmosphere of a planet that may be an ocean world. This revelation has intrigued and puzzled the astronomical community, raising fundamental questions about the possibility of habitable planets beyond our solar system. The planet under observation appears strikingly different from any known celestial body in our local system and suggests that other potentially life-supporting worlds might exist in distant regions of the universe. NASA's James Webb Space Telescope recently uncovered significant findings related to an exoplanet named K28a. This planet, which has a mass 8.6 times greater than Earth's, was found to possess carbon-containing compounds such as methane and carbon dioxide in its atmosphere. These discoveries support earlier research that hinted K2-18b could be a planet capable of supporting life. Evidence suggests it has a hydrogen-rich atmosphere and may be covered by an ocean. Initial exploration of K2-18b's atmosphere was conducted using NASA's Hubble Space Telescope, which revolutionized our understanding of this distant system. The planet lies 120 light-years away, within the Leo constellation, and orbits a cool dwarf star named K2-18. Significantly, K2-18b resides in the star's habitable zone, the region where conditions might be just right for life to exist. Planets, like K2-18b, which fall between Earth and Neptune in size, are not represented in our own solar system, making them relatively rare and of high interest to scientists. The presence of a hydrogen-dominated atmosphere, along with carbon-based compounds, has led astronomers to consider that such planets could offer the right conditions for detecting signs of life. Notably, the absence of ammonia in its atmosphere, coupled with the presence of methane and carbon dioxide, suggests the possibility of a subsurface ocean beneath the hydrogen-rich layer. Another intriguing detail emerged with the potential detection of dimethyl sulfide, DMS, a chemical produced exclusively by biological processes on Earth, primarily from phytoplankton in marine ecosystems. However, the evidence for DMS on K2-18b remains weak and requires further observation for confirmation. Astronomers plan to continue examining K2-18b using the Webb telescope and a global network of telescopes. One astronomer from the University of Cambridge emphasized that although the planet is within the habitable zone and contains carbon-based molecules, this does not confirm it can support life. With a radius 2.6 times that of Earth, K2-18b likely has a massive, high-pressure, icy mantle similar to Neptune, overlaid by a thinner hydrogen atmosphere and possibly a liquid ocean. Still, the nature of this ocean, whether it is capable of supporting life, is uncertain. Despite these uncertainties, researchers have obtained the most detailed atmospheric spectrum of a habitable zone sub-Neptune to date. A researcher from Cardiff University explained that this achievement was made possible by analyzing starlight as it passed through the planet's atmosphere during transits, periods when K2-18b crosses in front of its host star from our point of view. K2-18b is classified as a transiting exoplanet, meaning it periodically dims its host star's light as it passes in front of it. This method was how NASA's K2 mission originally detected it. During these transits, a small fraction of the starlight filters through the planet's atmosphere before reaching telescopes like the James Webb. This process leaves behind spectral signatures that astronomers can analyze to determine the chemical makeup of the atmosphere. To verify the potential presence of dimethyl sulfide and to better understand K2-18b's climate, the research team plans to use the Webb telescope's mid-infrared spectrograph in future observations. Their long-term objective is to search for signs of life on habitable exoplanets, an endeavor that could transform our understanding of the universe and our place within it. Beyond this, the James Webb Space Telescope has made other groundbreaking discoveries. For instance, it has detected complex organic molecules, similar to industrial smog or smoke, in a galaxy billions of light-years away. This represents the earliest known presence of such complex organic compounds in the universe. The discovery is both astonishing and unsettling as it challenges foundational assumptions in cosmology. These carbon-rich molecules, known scientifically as aromatic hydrocarbons, are commonly found on Earth in materials such as petroleum and coal, and in polluted atmospheres. What makes their detection extraordinary is the complexity of these molecules. They consist of dozens or even hundreds of atoms, unlike simpler compounds like water or carbon dioxide. This galaxy, where the molecules were detected, formed when the universe was just about 10% of its current age, roughly 1.5 billion years after the Big Bang. Considering the universe is now around 13.8 billion years old, the fact that such complex chemistry occurred so early is groundbreaking. It implies that the formation of organic complexity began far sooner than previously thought, forcing scientists to reconsider models of cosmic evolution. Thanks to the exceptional capabilities of the Webb telescope, astronomers are now able to study these ancient galaxies in unprecedented detail. Unlike earlier instruments, which could only confirm the presence of such molecules, Webb allows scientists to pinpoint where in the galaxies these compounds are located. In one case, a galaxy called SSPT 041847 was found to contain these complex molecules, although their distribution within it remains unexplained. Even more astonishing is the fact that SPT 041847, despite being so young, is already as massive as the Milky Way and has produced similar amounts of carbon and oxygen. This implies an incredibly fast pace of star formation and chemical evolution in the early universe. As humanity continues to push the boundaries of cosmic exploration, each new discovery deepens our understanding and challenges existing paradigms. With every revelation brought forth by the James Webb Space Telescope, we inch closer to uncovering the secrets of the cosmos. The universe is vast, mysterious, and brimming with possibilities, and it's only a matter of time before even more astonishing truths come to light.